Every time you type on your phone, you are seeing a simple version of a large language model. You type a few words and the system tries to guess what comes next based on probability. Mathematically, we can look at this as a function where the input is your sentence and the output is the most likely next word, like Matt appearing after the sentence, the cat sat on the. Welcome to CareerLink. Today, we shall be discussing the very foundations of how large language models, LLMs like ChatGPT work, especially focusing on students, researchers, and developers. First things first, while this sentence prediction mechanism might look obvious, it actually involves long mathematical steps. The goal in such a prediction is always the same. Take a sequence of text and predict the very next piece of that sequence. But here's the catch. Computers don't understand letters or words. They only understand numbers. We start by breaking a sentence into tokens and assigning each word a unique ID number. From there, we use an embedding matrix to turn those IDs into a long list of numbers called vectors. These vectors represent the meaning of any word in a mathematical space. As talked about in our previous video, these vectors represent coordinates in a giant 3D space. In this space, vectors of words with similar meanings like cat and kitten are placed together. Words that have nothing in common like toaster are far away. However, a single word like cat can be ambiguous, so the model needs more than just a dictionary definition. And this is where the transformer block comes in. Its job is to take those static word vectors and make them context aware. It looks at the words around sat and realizes it's not just any sitting, it's a cat sitting. This process of looking at surrounding words to gain context is also called as attention. To figure out context, however, the model uses queries, keys, and values. First, the input vector of any word, in this case sat, is converted into a query vector by multiplying with a weight query matrix. We have talked about weights in our fine-tuning video, so if you feel confused, feel free to watch that video. Now, once the word sat is converted into a query, think of it this way. Imagine the query for the word sat asking, I am a verb. Who is my subject? It then checks the keys of all other words in that particular sentence. It is similar to how English grammar works. When it finds a match with the word, in this case cat, it knows exactly which information is relevant. And we calculate this relevance using our dot product. A high mathematical score means a high relevance in this case. By running these calculations for every word against every other word in the sentence, the model builds an attention matrix. This grid shows exactly how much focus the model should put on each part of the sentence to understand the whole thing. You can pause the video if you like. We then use a formula called Softmax to turn those raw relevance scores into percentages that sum up to 100%. In our example, the word sat might give 72% of its attention to the word cat. We then add that feline context, which is also called value in this case, into the original vector for sat, creating a new, much smarter version of the word sat. However, the model doesn't do this attention calculation just once. Rather than a single attention, it uses multi-head attention to look at the sentence in many ways at the same time. One head might focus on grammar rules, another on the actual meaning of the words, and another on the long-range context. This allows the machine to grasp the complexity of human speech in many ways. After the attention phase, the data moves into a feed-forward network. This is a massive layer of calculations, often with tens of thousands of dimensions, that processes the context-based information. It is here that the model refines its thoughts and prepares to make final prediction. To keep the original information from getting lost in all this math, we also use what we call as our residual connections. We essentially add the original input back into the processed output. These, combined with normalization layers, ensures the signal stays clear and stable as it moves through the system. A single transformer block is powerful, but modern large language models stack dozens of them, sometimes even up to 96 layers deep. Each layer builds on the last layer, gradually tuning simple word IDs into deep mathematical representation of the entire input sequence. Once the data passes through the final block, we multiply it back against our dictionary to get Logits, or what we call as raw scores, for every possible word. In our case, we got the raw prediction scores for math to be 4.1, which is highest in this case. We use Softmax one last time to turn these scores into probabilities. If the math word has the highest percentage, that's the word the model chooses to output. As the model picks the word math, it is then finalized to showcase the word to the user on the screen. The model now takes that new word math and adds it to the end of the original sentence. Let's go back to our first demonstration. It might then feed this longer sequence back into the sentence to calculate the next word. For example, peacefully in this case. If you have noticed the output of ChatGPT, this is why you see ChatGPT type out one word at a time. It shows you each result as soon as it is calculated. And this is the calculus of language. By treating words as vectors and context as matrix multiplication, we can teach a machine to basically communicate with us in a way that feels natural. And the real miracle is scale. When you apply this math across 175 billion parameters and nearly all the text on the internet, you get an AI that can reason, create, and solve problems as well. Mathematics is the reason turning a simple prediction into the AI technology we use today. It's the reason why you can look at this cat sleeping peacefully on a mat, and ChatGPT can easily detect that visual and describe it for you. It turns out you just need a few billion calculations to make sure the cat lands on the right mat. If you are interested in more such AI-related contents, please make sure to visit careerlink.ai to join upcoming AI circles, explore resources, tools, and use cases to help you succeed in your AI journey. That's it for today. Thank you and see you on the next video.